let us see second application of this mesomeric effect. Meta-directing property and ring deactivating property of all minus M groups in benzene towards electrophilic substitution. That means if any electron withdrawing groups are present on the benzene already, if a new group you are introducing irrespective of the nature of the new group, if it is electrophile, that is only the condition. It can be a chloro or nitro or sulfo, but if it is electrophile, according to the nature of this minus M, the incoming group is directed to the meta position, that is third position. A suitable example is if you take benzene having an aldehyde function, that is benzaldehyde. Okay, let us take a benzaldehyde. Benzaldehyde, when you are chlorine and in presence of some ferric bromide or chloride, heat it for some time. Then one chlorine enters into the ring. Where it comes means it goes to the metachlorobenzaldehyde comes. The other products like ortho and para almost negligible amount, but the almost total quantity converts into the either this place or that place. They are identical, so therefore you will get a metachlorobenzaldehyde. Benzaldehyde will give the metachloro or 3-chloro. Metachlorobenzaldehyde. Now again here you have to observe the two things. One is where it is going, only third position. Now the reason comes why it is going to the only third position means you write the resonance structure of the benzaldehyde and you will come to know what is the reason. The C double bond O will have an original polarity like this. Consequently, the double bond is induced to polarize the outside. So, you will get a positive charge at the ortho position. Let me write the resonance structure of this benzaldehyde separately, having a positive charge at the ortho position, and here will become a double bond, the O will become minus charge. And if this double bond comes then a positive charge is shifted here, and subsequently if this is shifted you will get a plus here. So finally in the ring at ortho para ortho you will have a positive charges. So under this condition, if a Cl plus is going to attack, it cannot attack on the ortho para, because this is electrophile and there also positive charges are there. Positive cannot attack on the positive. So therefore what are the other chances means these two meta positions are not having the positive charge. Not having the positive charge, how this plus attack means this double bond opens and becomes a minus charge and then attacks. That's why it goes to the only to the meta, especially not at ortho para. So this group makes not to attack at ortho and para by decreasing the electron density. So at meta and meta there is no influence, but at ortho and para electron density is decreased. Electrons are taken away from the ring into the group. So such a group is called what? Minus mesomeric group. So all the minus M groups will do the same thing and directing or makes the incoming group to the go to the meta position. And second case, when compared with the reaction of a normal benzene chlorination and benzaldehyde chlorination, because in the ring overall including at meta also, because there is a positive charge, some electron density will be shifted. So even at meta position, at ordinary benzene meta and this meta position, if you see this meta position electron density, overall electron density in the ring also will be decreased. So therefore the rate of reaction also will be slow, or the type of reaction will be difficult. So when compared with the ordinary benzene, the reaction is difficult. That is what we are noticing as a ring deactivating property. That is overall reaction rate or the type of reaction, readiness of the reaction is decreased. So it is showing all minus M groups are showing two qualities. One is it is directing to the meta, it is making the reaction difficult when compared with ordinary benzene. So therefore the order of reactivity will be different compounds when I take a group which is showing a plus M group like a OH is more reactive than a benzene, okay, ordinary benzene, and the benzene is more reactive than a group like a aldehyde. So a plus M groups containing groups are more reactive than benzene, and minus M groups showing groups are less reactive. So this is the overall in general observation. Whenever plus M is there, ring is said to be more reactive, that is called activating property. Whenever minus M groups are there, overall reactivity decreases. Specifically, it is towards a electrophilic substitution reaction. Now, what are the other examples that show this type of the property? Means one group, let us show that first aldehyde group, this is right, and the group which is instead of hydrogen, if you have any alkyl or aromatic, called keto group. So aldehydes, ketones, and the groups like COOH, these are called acids, and the groups like C double bond O with some Y group. The Y can be a halogen, then we call acid halides. If it is OCOR, that is called acid anhydrides. If it is OR, it is called acid esters. If it is NH2, it is called acid amides. Now the list is aldehydes, ketones, acids, and acid derivatives. There are 4 acid derivatives are there. So all these groups, including, then we have some groups like N double bond O, NO, nitro group, sulfonic acids, and the groups like cyanide. So again, should I remember all these groups by only by hearting? Means no, not necessary. You have some certain features are there. In the plus M group, what was the feature? Like for example, OH, there was a lone pair on the first element. Now here, if you see here, there is a nitrogen is known for the lone pair, but there is no lone pair. It is given to the oxygen, no lone pair. On the sulfur, no lone pair. These are all carbons, no lone pair. Carbon, no lone pair. So the first element should not have a lone pair. This is the first condition. Second condition is the first element should have some double bond or a triple bond like this. Multiple bond should be there. On the first element, there should be a multiple bond. Third condition is this multiple bond should have some hetero atom, not the CC bond, CO, NO type of hetero type of multiple bond, in which the more electronegative element is that side, so that the electrons are taken away, driven away from the ring to the group. So the polarization will be this type. Then the ring, from the ring electrons will go, and these groups act as a minus M. So by seeing itself, you can recognize the first element should not have a lone pair. It should have a pi bond and hetero type of pi bond. The more electronegative should be the other side, so that electrons will be taken away. So all will have the CO, NO, SO, CN, all this. So these are all the groups will do the same thing, that is, they direct the incoming group to the meta, as well as the rate of reaction will be decreased. So therefore, and these groups will have this particular behavior. So one can have a number of exercises when compared, that is 1 and 2 together. Also we can have some combined the examples. Now for example, I want to prepare from benzene, I want to prepare a compound like a chlorine and a nitro group. Where is that nitro? At third position. This is called metanitro-chlorobenzene. Metanitro-chlorobenzene. I want to prepare this compound from the benzene. The two groups can be obtained by their classical method, that is by using chlorine, ferric chloride, chlorination, concentrated nitric acid, concentrated sulfuric acid mixture taking nitration. This is the chemistry part actually. But the point is here, should I prepare first chlorobenzene, then nitrate it, or first nitrobenzene, then chlorinate it? Two methods are possible to prepare such compound. But the correct method is first go for the nitrobenzene. Prepare a nitrobenzene first. then for the chlorination, then you will get right answer. Instead, if you prepare a first chlorobenzene, then nitration. Nitration gives the ortho and para products. This is the wrong answer in fact. I want meta. So the nitro group has a meta directing property, therefore introduce first nitro, then go for the chloro. So here, so to prepare this particular compound, this particular order is correct, this order gives a wrong answer. Okay, right. Like that we have a huge number of questions. In the IIT also we have some questions like this. There are two benzene rings attached to a OCO group. How many functional groups are there? Only one group, but two benzenes are there. Let us designate this benzene as a ring A and the ring B. Now I want to treat it for a bromination, that is specifically I allow only one bromine. So the condition I put monobromination. So I want to brominate it, this compound, to get a product, that also I am restricting. The major product only you write, major product you write. The other products I am not interested, minor product, small quantities I am neglecting. So what is the major product in the monobromination of this compound? The question should be handled in three levels. First one is, which ring will react? Will the ring A react or B reacts? Which ring will react? So the ring A and B has got only one group. This group is it plus M or minus M means here. The ring A is attached with an atom which has a lone pair. So the lone pair can donate. So therefore ring A has got a plus M group attachment. What about the other one? Means this is only one group, but that end attached to the benzene is now having a C double bond. It will pull out the electrons. The ring electrons will come out. So therefore this group acts as a minus M group. See the group, only one group, that is an ester group actually. That ester group, this side is through O, that side is keto. So this group is acting plus M, this group. So this benzene is having a plus M group, that benzene is having a minus M group. This is activated. So therefore answer here is ring A is the answer. So ring A is going to react and giving the major product. Second level is the ortho or para, ortho, para or meta. Will the group is going to occupy ortho para positions or meta position? Then this is a activating, that is plus M group. So not the meta. Answer is here ortho para. Ortho and para answers we are going to get. The third level is, out of the ortho para, is it ortho or para? The question is between the ortho and para, which is dominating. Now we have another factor, that is actually steric hindrance is also involved in this question. Due to the steric hindrance, when this big group is there, the reagent coming at ortho positions is slightly difficult, isn't it? Adjusting the group is difficult, therefore the group goes to the para. So the answer is here para. That means the answer goes to here and takes a reaction. So the answer comes out as like this. At para position a bromine comes. Rest of the group compound will be intact. This will be your answer. Para-bromo. Para-bromo phenyl benzoate will be formed. This is called phenyl benzoic acid ester with phenyl. So alkyl you say first. Phenyl benzoate. So this is para-bromo phenyl benzoate is formed. That is the right answer. That is the major product formed is para-bromo phenyl benzoate. So the direct answer we are taking in three different levels. First question is ring A or ring B. This is decided based on the activating property of the group attached. So A is attached activating, so A undergoes reaction. Like that, second aspect is out of that the ortho-para meta, which is the actual answer, means ortho-para, because activating groups are ortho-para. Out of ortho and para, however, here the not based on the mesomeric effect. Here the effect is called steric hindrance, that is the another factor. At the end we are going to deal with this one. So, according to the steric hindrance, the group coming ortho will have some steric problem, 3-dimensional problem. So, therefore, the group prefers to attack, because bromine is also considerably bigger group. So, it goes to a pair position and then attacks. Like this, we have huge number of applications in which the first and second, both the applications we are applying. It is not only the second application. First application is ortho para directing property and activating, and second application is meta directing and ring deactivating. So, therefore, both the qualities, that is application of 1 and 2, we are applying in this question and then able to solve the problem. Let us see another small question. I want to prepare this particular compound. NO2. This is a 2 phenyls having a ketone. This is called diphenyl ketone. In one ring we have a methoxy group, the other wing it is nitro. Okay. So, one side let us number like this 1, 2, 3, 4, 4 methoxy, and the other side let us number like this 1 dash, 2 dash, 3 dash. Okay. So, 4 methoxy, 3 dash nitro diphenyl ketone. This compound I want to prepare by using a reaction called take one benzene, introduce a benzene with CO group, that is called Friedel-Crafts acylation reaction. You can prepare this compound from the 2 different sources. In one method, take a methoxy benzene, take methoxy benzene OCH3 and treat it with the benzoyl chloride containing a nitro group at para position. Now, this in presence of anhydrous aluminum chloride holds this Cl minus temporarily, you get a plus. This plus will go and attack at which position? Because it is a plus M group, it is activating. So, the ring will undergo very fastly reaction, a facile reaction, and specifically it will go and attack at the para position because it is para directing. So, beautifully you will get this compound. So, this is in fact the first method happens to be the right method. You too can prepare the other way also. What is that other way? Take a nitrobenzene, treat it with the methoxy group containing OCH3 containing acetyl chloride. This is also gives the same answer, because the aluminum chloride here also, if you take as a catalyst, will holds the Cl minus and you will get a cation where it will go attack at meta position, because nitro group is a meta directing, it will go into meta. That is what I want, meta relation is needed. So, the relation, that is meta directing property wise, there is no problem, both will give the para substituted product, para to this one, meta to this one. So, there is no problem. But in the second scheme, we have a defect. What is that? The nitrobenzene is deactivating the benzene. Therefore, the rate of reaction of the benzene is slow. And the another one is also, this is a electrophile. In the electrophile, we have a donating group. Electrophile is a one which should have a positive character, more the electron deficiency, then it will be a strong electrophile. We have a now electrophile generated which is having a plus M group. So, the positive charge, effective positive charge will be less. So, then attacking will be slow. So, therefore, this you can term as a poor electrophile, and the poor benzene is deactivated, a poor compound and a poor attacking species. The net reaction will become slow here. So, this is not a fair reaction, it is a slow reaction takes place. Whereas, here a benzene which is activated, a better compound, substrate is better, and this is deactivating, isn't it? The nitro is a minus M group, it's deactivating. So effective positive charge will be very strong, it is withdrawing. So therefore in the ring you have a deficiency that will create from here, so this also will become a brighten up. So therefore the effective positive charge on the electrophile is strong. So electrophile should have a minus M group, in the compound should have a plus M group, both have become activated and the reaction takes place very softly. So either way you can prepare, but the scheme 1 will be the right method to get the more quality, that is the product, the percentage of the reaction will takes place in the scheme 1 in a better way. The other way also you will get the same compound, but in a lesser quantity you will get, because you have two negative features. In the compound deactivating, in the reagent it is subsiding the positive charge, therefore that is also another negative factor. Two negative factors are there in that, two positive factors are in this one. So therefore the reaction becomes a more facile or more ready reaction takes place in the scheme 1 when compared to the scheme 2. So in this also we are using this minus M plus M, activating, deactivating, orthoparadirecting and metadirecting, both the qualities we are together we are discussing and analyzing or the applying the concept on the same issue is one, but both the concept at a time we are able to use it.